Today, we're taking a journey deep inside the most complex machine on Earth, your mind. We're going to pop the hood and explore its operating system. All the hidden processes that instantly turn what you see and hear into thoughts, memories, and actions. I mean, have you ever stopped to really think about it? You see something, and in less than a second, you've got a name for it, a memory tied to it, maybe even an opinion about it. How does that even happen? What is going on in there? To really get a handle on how we think, we have to follow the entire journey of just a single piece of information. From the moment light hits your eyes to the point where you're solving a problem with that info. That entire path, input, processing, and output, that's the absolute core of the cognitive approach. Okay, let's dive right into this. A great way to think about the cognitive approach is to see it as the study of the mind's software. The programs that are running everything behind the scenes. So, while some other approaches might just look at a stimulus and your response, the cognitive approach is totally fascinated by what happens in that crucial gap in between. These are the so-called mediators, all the thinking, all the remembering, all the deciding that connects what you experience to what you ultimately end up doing. Let's start right at the beginning of that information journey, the input stage. This is all about how we take in the world around us and, way more importantly, how we start to make sense of it all. It's funny, we used to think of perception and cognition as two totally separate things, but now we know that the line between them is incredibly blurry. I mean, you don't just see a coffee cup, you instantly recognize it as a cup because your memory, a cognitive process, is already telling you what it is. It's instantaneous. And this right here illustrates the point perfectly. Take a look at this ambiguous figure. If I prime you, if I say the word glasses, that's probably what you'll see. But if I say barbell, you'll probably see that instead. It's wild. Your existing knowledge, your mental schemas, literally shape what you perceive in real time. All right, so the information is in and it's been perceived. What happens next? Well, it gets processed and stored. And this brings us to the architecture of your memory, which is this incredible internal system that works a lot like a computer. The classic model breaks it down into three main stages. First up, you've got sensory memory, which is just this split-second echo of what you just saw or heard. If you pay attention to it, it gets promoted to short-term memory. Think of this as your mind's active notepad. And from there, it might just get encoded into long-term memory, the vast hard drive of all your experiences. Let's really dig into that computer comparison because it's a good one. Short-term memory, which we often call working memory, is a lot like your computer's RAM. It's super fast, super active, but it has limited space and only holds on to things for about 15 seconds, unless you're actively rehearsing them. Long-term memory, on the other hand, well, that's your hard drive. It's a little slower to access, but has a seemingly infinite capacity for storage. So, if we have this massive hard drive in our heads, why do we forget things all the time? Well, it happens in a few ways. Sometimes the memory trace just decays, fades away. More often, new information comes in and displaces the old stuff. Or you get interference, where similar memories get all mixed up. Like when you can't remember your new password because the old one keeps popping into your head. And finally, sometimes the memory is there, but you just don't have the right cue to find it. Kind of like trying to remember a classmate's name when you see them at the grocery store. But here is maybe the most profound idea about memory. It is not a perfect video recording. It's a reconstruction. Every single time you recall something, you are rebuilding it, sometimes mixing in new information or suggestions. This is exactly why the work of researchers like Elizabeth Loftus is so critical. It shows us that something as important as eyewitness testimony can be easily changed just by the way a question is phrased. So we've taken information in and we've stored it. Now for the final step, the output. How do we actually use all this stored knowledge to solve problems and, create new ideas? There are two major ways of looking at this. The Gestalt approach is all about insight, that sudden aha moment when you kind of restructure the problem in your mind and the solution just pops in. Then you have the information processing approach, which is much more methodical, almost like a computer running an algorithm, just breaking the problem down into a series of logical steps. And what about creativity itself? Well, the crucial point here is that it's not just about being unique. An idea has to be useful to be considered truly creative. You could invent clothes made of spaghetti. I mean, that's definitely unique. But since it's not really practical, it doesn't quite hit the mark. This all brings us to what is perhaps the most complex and powerful cognitive output we have, language.
It really is the ultimate tool we use to organize our thoughts and communicate them to the entire world.
And one of the most fascinating questions out there is whether this ability is uniquely human. We've seen some amazing studies. Chimps like Washoe learned sign language, and bonobos like Kanzi learned to use symbol keyboards just by watching. But the debate still rages on. Are they truly using language with all its grammar and syntax, or are they just really, really good at association? The jury is still out on that one. And that leaves us with a final, really mind-bending question to chew on. This is the heart of what's known as the Whorfian hypothesis. Does the language you speak just express the thoughts you already have? Or does its very structure, its words for color, its concept of time, does it actually shape and even limit the very thoughts you're capable of having? It's a profound idea about the code that runs our mental OS, and definitely something to think about.